clear distinction can be made between the two bodies of water, as the lighter Atlantic waters stand next to the darker Pacific waters.
At the far edge of the Americas, where the continent tapers into wind-scarred cliffs and roaring seas, two colossal oceans confront one another with forces shaped across millions of years. One is turbulent and impulsive, the other vast and ancient. Yet their meeting forms a boundary that is neither fully conflict nor harmony. Today we journey into this extraordinary encounter to understand what truly unfolds when worlds converge. The edge of the world. At the southern tip of South America, Cape Horn rises like a jagged monument to the power of nature, creating a threshold where the Atlantic and Pacific Oceans collide with remarkable intensity. The surrounding waters, sculpted by relentless winds and towering swells, form a crucible in which sailors have long confronted some of the most unforgiving conditions on the planet. The mountains of Tierra del Fuego stand nearby as silent witnesses to this turmoil, their glaciers feeding the sea with icy torrents that only heighten the region's volatility. Every gust, wave, and current here becomes part of a larger choreography, shaped by geography, temperature, and deep ocean forces. The Atlantic approaches with a restless energy, driven by strong eastward currents that reflect its youthful dynamism and long history as a corridor of exploration and trade. The Pacific, older and far more expansive, presses westward with the measured persistence of an ocean, shaped by ancient tectonic rhythms and vast internal tides. Their convergence forms a dynamic boundary that cannot be drawn on any map, since the forces at play shift constantly with the winds, seasons, and pressure systems sweeping across the southern hemisphere. This region invites observers to consider not only the ocean's visible fury, but also the deeper mysteries concealed beneath their turbulent meeting. The long memory of oceans. Long before humans charted coastlines or traced wind patterns across maps, the Atlantic and Pacific were already sculpting the planet's climate through forces set in motion hundreds of millions of years ago. The Pacific, the oldest surviving ocean basin on Earth, carries within its depths the geological memory of shifting plates, vanished continents, and ancient seawater trapped in its trenches. Its enormous size allows it to generate powerful currents that influence weather systems across Asia, the Americas, and Oceania, creating patterns like El Niño and La Niña that can alter rainfall, disrupt fisheries, or intensify droughts half a world away. The Atlantic, younger but no less influential, emerged from the fracturing of supercontinents, gradually widening into a corridor that distributes heat from the equator toward northern latitudes. This warm flow, including the system of currents that moderates European winters, demonstrates how the Atlantic's movements shape human history as much as natural ecosystems. When these two oceans approach one another near the southern tip of South America, they do so under the influence of forces that extend far beyond local geography. The Drake Passage, the narrow expanse between Cape Horn and Antarctica, acts as a powerful funnel through which the world's only uninterrupted band of oceanic current flows. Known as the Antarctic Circumpolar Current, this relentless river of water sweeps from west to east, without encountering a landmass to slow its momentum, gathering energy from the roaring winds that encircle the polar continent. As it accelerates, it draws the Atlantic and Pacific into a turbulent exchange, pulling their waters into a zone where temperature, salinity, and density differences begin to dictate how they interact. These forces set the stage for a meeting that influences not only regional weather, but the planet's broader climate rhythms, the hidden boundary. When ships enter the waters where the Atlantic and Pacific converge, many sailors describe an unsettling sight. A visible line in the sea, where blue and green currents run alongside one another, seeming to resist blending despite the restless surface. This striking boundary is not the illusion of a weary traveler, but the product of real physical contrasts shaped by temperature, salinity, and density. Atlantic waters, typically warmer and saltier due to evaporative processes at lower latitudes, behave differently from the colder, fresher waters of the Pacific that descend from the subpolar regions. As these two masses approach one another, their molecular structures determine how quickly they can mix, creating a temporary seam that lingers before turbulence eventually dissolves it. Although this boundary has inspired myths of oceans separated by supernatural forces or geological barriers, the truth is far more complex and scientifically revealing. The interface operates like a dynamic membrane, shifting with seasonal winds, storm activity, and variations in regional climate patterns. Even the slightest change in temperature or pressure can tilt the balance, allowing one body of water to slide above or below the other in a layered formation known as stratification. This layering influences nutrient distribution, wave behavior, and the paths taken by marine species migrating through the region. The phenomenon also serves as an indicator of subtle but powerful processes occurring beneath the surface. Differences in density affect vertical circulation, which in turn helps determine how heat and carbon are transported across the planet. This interplay reveals that the meeting of oceans is not simply a dramatic visual event experienced by those who venture to Cape Horn. It is a scientific window into the delicate equilibrium governing Earth's interconnected systems. These hidden mechanisms guide the transition toward deeper revelations about the ocean's long-term influence, ancient cycles that reshaped Earth. As scientists probe deeper into the question of how these oceans interact, they uncovered evidence suggesting that the meeting of the Atlantic and Pacific has influenced Earth on timescales far longer than human civilization. Sediment cores extracted from the floor of the Drake Passage revealed alternating layers of mineral content, microfossils, and isotopic signatures that recorded fluctuations in water movement between the two basins. These variations were not random. Instead, they pointed to a recurring pattern in which the strength of the exchange between the oceans shifted dramatically every few thousand years. During certain periods, the Pacific exerted greater influence, pushing warmer, nutrient-rich water toward the Atlantic. At other times, the Atlantic dominated, enhancing the global flow of heat toward the northern hemisphere. This discovery reshaped scientific understanding of the ocean's role in climate history, because these shifts aligned with abrupt temperature changes documented in ice cores from Greenland and Antarctica. The weakening of the Atlantic's overturning circulation during Pacific-dominant phases appeared to correspond with rapid cooling events that transformed weather patterns, altered rainfall across continents, and disrupted ecosystems from the tropics to the poles. These cycles, driven by natural forces such as tectonic movements, orbital patterns, and changes in polar ice, demonstrated that the oceans possess a capacity for planet-wide influence, far more substantial than previously believed. The researchers who pieced together this evidence, working across institutions in the United States, Europe, and Chile, emphasized that these oscillations were part of Earth's natural rhythm, rather than anomalies. Yet the implications were profound, since they revealed a climate system highly sensitive to subtle disturbances in salinity and temperature. The convergence at the bottom of the world, once viewed as a regional curiosity, emerged as a powerful engine capable of reorganizing Earth's climate on a global scale, preparing the narrative for the consequences still unfolding today. Consequences of a fragile balance. The realization that shifts in the Atlantic-Pacific exchange once contributed to abrupt climate events reframed how scientists interpret both ancient transformations and contemporary risks. Past disruptions in salinity or temperature did not merely alter local conditions. They cascaded across continents, influencing monsoon strength, storm formation, and the migration routes of marine species whose survival depended on stable ocean pathways. Civilizations that thrived along coastlines or river systems often experienced the indirect consequences of these changes, whether through altered rainfall patterns, diminished fisheries, or unexpected episodes of regional cooling. These historical echoes illustrate how intimately connected human societies have always been to the unseen rhythms of the sea. Today, the balance appears more vulnerable than at any point in recent millennia. The accelerated melting of polar ice introduces vast amounts of fresh water into the oceans, reducing salinity in critical regions of the North Atlantic, where dense, salty water typically sinks to drive the planet's overturning circulation. If this process weakens significantly, even modest alterations could influence storm tracks across Europe, intensify heat in equatorial regions, or disturb nutrient upwelling zones that sustain major fisheries. Although scientists caution against assuming immediate catastrophe, they agree that the system is exhibiting measurable signs of stress. The implications extend far beyond academic concern, since the ocean's circulatory strength determines how heat and carbon are distributed throughout the globe. As atmospheric temperatures rise, understanding the delicate interplay between the Atlantic and Pacific becomes essential for anticipating future climate behavior. These uncertainties set the stage for examining how humans have interacted with this volatile crossroads throughout history. Human stories at the threshold of two oceans. For centuries, the region where the Atlantic and Pacific converge has drawn explorers, sailors, and researchers who sought to understand forces far greater than themselves. Early navigators approaching Cape Horn encountered winds capable of shredding sails and waves that dwarfed their wooden vessels. Yet they pressed onward because crossing this boundary promised new trade routes, scientific discovery, or the simple affirmation of human resolve. Their journals describe nights when the sky vanished behind curtains of spray, moments when compasses faltered under magnetic interference, and days when progress amounted to little more than holding position against the current's relentless pull. Modern travelers arrive with sturdier ships and advanced forecasting tools, yet they remain humbled by the same elemental power that challenged their predecessors. Oceanographers deploying instruments into the Drake Passage work amid swells that threaten to overturn research vessels, while divers and engineers studying marine ecosystems confront cold, fast-moving waters that test the limits of equipment and endurance. These stories underscore a shared truth. Every person who ventures into this meeting of oceans participates, however briefly, in a dialogue between humanity and nature that has shaped curiosity, ambition, and resilience across generations. The place where two oceans collide reminds us that Earth's balance depends on forces both ancient and exquisitely fragile, shaped by choices made far from Cape Horn's restless horizon. If this journey deepened your understanding of our connected world, please like the video, subscribe for more explorations, and join us as we uncover what lies beyond the next horizon.